Hello and welcome to helpyourmath.com. In this video, we are going to look at determining if a relation is a function given its equation. First, let's review when is a relation a function. A relation is a function when each input maps to exactly one output. What that means is that for every x, it maps to exactly one y and only one y value. So for example, if we have an input of 2, it maps to exactly or only 4. It doesn't map to 4 and to 12. If we are given an equation, there is no magic way to determine whether it is a function or not, so unfortunately that's too bad. What we can do is keep some facts in mind, and what really helps is visualizing or try to picture what the graph would look like. So for example, if you're given a polynomial absolute value, square root, reciprocal, or rational equation when y is in terms of x, those are all guaranteed to be functions. So you'll never have to worry about those are always going to be functions. If you have to do something weird to get y by itself, it is likely not a function. It's not guaranteed to not be a function, but it could be a function, it might not be a function. Again, it really helps to visualize these as graphs. Okay, so let's look at some examples. The first example, we have x squared plus y squared equals 49. Do you know what type of relation that is? That's actually a circle. To get y by itself, we would need to subtract x squared from both sides. So we would have y squared equals 49 minus x squared. And now to get y by itself, do we have to do something weird? We do. What we have to do is we need to take the square root of both sides. And when you take the square root of that right-hand side, the 49 minus x squared, you have to include the positive or negative, which means y is going to have two possible outcomes because it's going to be the positive or negative version. This is not a function. And again, if you envision the graph, this would be a graph with a center at the origin and a radius of 7, and you can see it will badly fail the vertical line test. So if we draw just a visual representation, it would be a circle. You can see it fail the vertical line test pretty much everywhere on the graph. Okay, in our next example, we have y cubed equals 81 minus x cubed. To get y by itself, what would we need to do? We would need to take the cubed root of both sides. What happens when we take the cubed root of both sides? Well, we'll end up with y is equal to the cubed root of 81 minus x cubed. Because it's an odd index, or we took an odd root, we don't include that positive or negative. With the odds, we don't have to worry about that the way we did with the even in that previous example. So we end up with just y equals the cubed root of 81 minus x cubed. So even though we did do something kind of weird, this one is a function. It turns out this one is a function because we don't have that weird positive or negative in this scenario. And again, if you can, let's look at the graph. So there's the graph of y equals the cubed root of 81 minus x cubed. You can see that it will pass the vertical line test. In our next example, we have 4x minus 5y is equal to negative 10. Do you recognize what that is? That is a linear equation. And as long as a linear equation is not a vertical line, if it's any other type of line, it will be a function. So we know this is a function because we know this is a slanted line. It's not a vertical line because there is a y. And if we want to graph it, we can verify that this line will pass the horizontal line test. If we find the intercepts, the x-intercept would be negative 2.5, and the y-intercept would be positive 2. You can see it passes the vertical line test. In the last example, we have y equals the square root of 25 minus x squared. This looks very similar to what we ended up with in that first example, but there's one key thing missing from the given equation, and that's that positive or negative sign. Because we don't have the positive or negative sign here, that indicates to me that this is a function. It very much looks like it's going to be a circle, but it's actually not a circle. It's going to be a semicircle. So let's look at the graph of y equals the square root of 25 minus x squared. So you can see it is a semicircle. It does pass the vertical line test. And so we see the difference there. It doesn't have that weird sign the way the first one did. Let's look at a few more examples. In this first example, do you recognize that type of equation? That's the equation of a circle. Therefore, it is not a function. This would be a circle with a center at 3, 1 and a radius of 6. And if you can visualize what a circle looks like, you know that that's going to fail the vertical line test. So it looks something like that. Not my greatest circle, but you get the idea that it's not going to pass the vertical line test. How about y squared equals x squared minus 9? What do you think? Well, to get y by itself, what are we going to have to do? We're going to have to take the square root of both sides. And when we take the square root of the right side, we have to put that positive or negative. So we have to do that to make it mathematically sound. Including that positive or negative indicates to us this will not be a function. And just to verify, we can see the graph. There's the graph. That graph is called a hyperbola. And we can see this will badly fail the vertical line test pretty much everywhere. It fails it right here, it fails it here, it fails it here. Not good, not a function. Okay, in our next example, we have y equals the absolute value of 7 minus x. This is an absolute value with y in terms of x. So this will be a function. As long as y is in terms of x, this will be a function. If we were to sketch a graph, this would be that upside down V shape, the absolute value function, and it will pass the vertical line test. How about the last example? We have the absolute value of y is equal to 3 minus x. This is not a function. This is x in terms of y, not y in terms of x. There's the graph. You can see it's going to fail the vertical line test. These have been examples of determining whether a relation is a function when given its equation. Thank you for stopping by.